What's going on, everybody? Welcome back to another episode of Trey Codes. I am, your main host, Trey Codes, here again. And today I wanted to do another Flame demonstration for another video game. This one is going to be a little bit more special and unique because this is a video game that we've all played, or maybe not all of us, but majority of us have an understanding of what the game is. And that game is Super Mario Brothers for the Super Nintendo Entertainment System. I decided to recreate this game because I felt that it had the complexity that would provide a very good understanding of everything that Flame can do, from all the different sprites, all the different animations, the map creation, the enemies, the collisions, all these things encompassed in one. I felt like Super Mario Brothers would do a great job as another demo for teaching Flame. So today I'll be remaking that game, showing you step by step how you can create the Super Mario Brothers game within Flame. So without further ado, as always, let's jump into this video. As always, before I actually jump into whatever video I'm about to discuss, I wanted to make sure that I give a special shout out to some of the videos that I use as references, or resources, a better word, for whatever I'm trying to learn about. And a lot of the times when I'm looking at tutorials for Flame games, there's a specific channel that comes to mind every time, and that is DevKage, DEVKAGE. Be sure to check his page out. He does a very good job explaining some of the components necessary for making your games in Flame. Very easy to follow when trying to understand all this material. So I'll be sure to drop a link to his YouTube channel as always. But yeah, just make sure that you use him as a reputable resource. So like I mentioned earlier in the beginning of the video, I'm going to be recreating the Super Mario Brothers game that was on the Super Nintendo Entertainment System. So there's going to be a lot of components related to this game, and I'm not going to be able to cover all of them in this single video, so I'm going to make this a three-part series. And for this first part, I'm going to focus on the basic setup, the creation of the map, the small version of Mario, because if you're familiar with the game, there's three different tiers of what Mario can turn into, which is the small version, super version, and the fire version. So for this video, it's just the small version. I'm also going to be demonstrating how to incorporate the Goomba enemy in the game, which is the first enemy that Mario sees when on level 1. I'm also going to explain the differences of both the brick block and the mystery block within the game. The brick block, I believe, he can just gain coins. Mystery block, he can actually gain certain items. And then last but not least, I'm going to explain how we can pause the game during game activity in case you have to take a bathroom break or something. So that's going to be the gist of what this video will be about. Alright, so before I actually get into the coding part, I'm going to be explaining the basic setup of what I have currently. A lot of what I'm about to explain are things that are just configuration files, global values, things dealing with the pubspec.yaml file, essentially because I feel it's better to have this out of the gate versus trying to do that on the fly during the demonstration, because these files are very information specific, and if anything is off, it can mess up our demonstration. So I'm just going to go over some of these things right now. So first, since we already have the pubspec.yaml file up, this is the file that holds all the Flutter packages as well as directories that you would need for your assets and a lot more. But things to note here are we're going to be using the Flame package, and we're on version 1.8.1, Flame Audio version 2.0.4, Flame Tiled 1.12.0, 1.12.0. Flame is what we use for the game itself. Flame Audio is for the audio files, and then Flame Tiled is what we use in order to convert our maps that we make in tile.io over to Flutter. We also need to specify these directories right here for our audio and images, and this is just an assets folder up here. It contains the audio that we have, and the audio that I have are sound effects that I got from, I forgot exactly where I got them from, but they're different sounds related to Mario in the game. For example, the power-up sound, and some of the images that we have, such as the sprite sheets for the blocks that we're going to be using, the Goomba sprite sheet, Mario walking, Mario standing still, the world itself, etc., etc. But just know that you would specify those paths within the pubspec.yaml file. Within the main.dart file, very simple, void main async setup, widgets flutter binding .ensure initialize. This is just called at the beginning of every Flutter app to make sure that everything's in place before we actually start performing logic within the app. We have this method called spritesheets.load, and I'll explain what this does in a second. I'm also pre-loading the audio files for the game, and this is to make sure that during the game we don't have to wait for sound to be registered, because it can cause a slight delay in game functionality and it wouldn't be an as smooth user experience. Then down here is just a simple material app with a center that says Super Mario Brothers. The sprite sheets this is a class that I made that's going to be loading those same sprite sheets from the assets folder, such as this one right here. We're going to be loading the sprite sheet, that way we can manipulate it within our app to know which image we're going to be taking from the sprite sheet. So for example, the mystery block would use this sprite sheet to begin with, but then once it's hit, it would then use one of these images in the sprite sheet. So that's the sprite sheet class. Animation configs. This is the animations through the game. So while Mario's walking, we have an animation to handle that. We have animations for when Goomba is moving, for when the mystery block or the brick block has been hit. Just know that this is where all the animations are going to be placed at. It's easier to set it up this way than trying to create the animations within the classes. And then last but not least, the globals file. This is where I keep a lot of constant values throughout the app, such as paths to different assets, time values, sizes, names of files, etc., etc. So I've got all these for the sounds, step times for when we're sequencing between sprite sheet animations, tile size. The default tile size for our map is going to be 16 by 16. Name of the first world, the sprite sheets that I talked about earlier, and then sprite sheets for Mario when he's idle or when he's jumping. This is all I have in here right now. Outside of that, this is the most simplistic bare bones Flutter app. So just know that this is square one when setting up the app. So the very first step of this tutorial is we need a map for Mario to actually play through. And if you're familiar with the game, the first level of the first world of Super Mario Brothers is pretty much this wide world where it's just bricks, platforms, and not too much difficulty to it. A few pitfalls, a couple jumps, and then he's at the end of the map. But luckily for us, we have the image of the first world, and so I'm going to be recreating that map within this application called tile.io. This is what I use and a lot of other developers use to create their maps within, or to create their maps to be used in Flutter. So I have the application opened up right here. We're going to select new map and make sure that you have the settings to orthogonal, base 64 uncompressed, right down, and then specify the width and the height. Now, the map, I did the calculations, the number of tiles, which is the squares on the map, is 211 by 15. This is not the pixel size, keep that in mind. These are the tiles. The pixel size is 16 by 16, but there are 211 by 15 tiles that are each 16 by 16, if that makes sense. So we have this set right, we'll hit OK. And now we have an empty canvas for where we can recreate our map. So we can go ahead and create a new tile set first that's going to be based off of the image of that map. So let me go here, assets, images, world 1, and we'll call this world 1_1 tile set. Everything looks right, save as, and we'll save this in our tiles directory. So basically what we just did was we converted that image into a tile set, and the tile set allows us to take different pieces of that image and paint them into our canvas. So if we come back over here to our tile set, or to our map, I'm going to copy and paste the entire world into this canvas, and it should fit perfectly like that. Okay, and it fits perfectly because I did it, like I said, the measurement was 211 by 15. So we now have our map. That's literally the only thing that we have to do in tile.io to get started. So now let's make sure that we save this, or actually export as. We're going to name it world_1_1 map, and it'll be saved as a .tmx file. All right, so that's all we need to do there. Okay, so now we can actually import our game into Flutter. So I'm going to close out these windows, create a new directory called games, and within here we will create the Super Mario Brothers game extends flame game, and we need to override the onload method, and within here we need to create a tile component, which is an object that represents the map that we just created. So we'll say tile component map equals tile component dot load, and we need to give it a file name, which is going to be the map right here, which is file name is world_1_1 map.tmx. So we're just going to call this global file and access the level 1_1 value. Replace file name with globals. Make sure that you do the proper imports for everything. I need to finish this out. And then the destination file size. Remember that the tiles are 16 by 16. So we'll use the tile size and the global value. And this is asynchronous, so make sure that you await this. It should work. Why is this? Oh, my bad. It needs to be a vector. Vector2.all, and we'll pass in that tile size. All right. Then we just need to add the map to the game. And now the game is set up right there. Now we need to come back to our main.dart file, create an instance of that game, Final Super Mario Brothers game, and then replace the center with a game widget. And then the game that we're going to pass in is that Super Mario Brothers game. Oh, remove the const value because it's no longer constant. Okay, cool. So if we run this, we should see the map that we created displayed in the screen. And something to keep in mind, I usually make these games in iOS or Android, but I decided to switch it up, and we're actually going to be developing this game in Chrome. So we're going to be in a browser today. So if we open this up, there we go. We have the Super Mario Brothers Level 1, World 1 now displayed in the browser. Okay, so we now have the world being displayed within the browser, but as you can see, the map, this isn't really doable. The entire map, well, not the entire map, but a huge portion of the map is being pushed to the very top, and it's zoomed out way too far. So we can fix this simply by taking control of the camera component within Flame. The camera component is a new API that the Flame engine is working with in order to provide a little bit more flexibility when it comes to viewing the game through the user's lens. So what we'll do is we'll come back to the Super Mario Brothers game and create a late component, camera component, and then we'll also create a world instance. And the world is essentially just a container of all the components that will go into the game. So every level, every character, every camera component would all go into this world object. We do the imports, and then within our onload, we are going to remove this add map because now we're not adding the map to the game directly, we're adding it to the world. So we'll say world add map, and then we need to create our camera component, okay? So there's a few configurations that we'll add. We need to modify the viewport and the viewfinder. And these two things are similar but a little bit different. So the viewfinder controls which part of the world is seen through the viewport. The viewport is essentially a window from which the game is observed. And I'll show you what the configurations are for that. So for the viewfinder, we want to change visible game size to be vector2 450 to 50. And what this is basically saying is how close do we want to be into the world. We can be farther out or closer in. And if we want to zoom in or zoom out, we will modify the x-axis or the y-axis values of this vector2 object. Then we need to change the viewfinder's position, and it's going to be 0 at 0 because we want to start at the beginning of the world. We also want to change the anchor to be anchor.top left. Oops, if I can spell it. I'm being lazy. Anchor.top. Okay, so that's all the configuration we have for the viewfinder. And then last but not least, we need to change the viewport. And that position is going to be a vector2 of 500 and 0. And we're doing 500 because with the camera component, since it's new, there isn't a clean way to constantly have the map displayed properly and follow Mario correctly. Right now, you kind of, how do I explain it? If the world starts at the very beginning, Mario, the screen doesn't really adjust to following Mario properly if the map starts at 0, 0. So we're pushing it back a little bit to give Mario space while he's walking through the world. That way, otherwise we would literally be on Mario's back as he's walking through the map, and that would be not a good user experience. So we'll finish that. And then finally, we need to come down and hit add all. We're going to add both the world and the camera component. And I'll take this import out because that's not needed. All right, now if we refresh this, cool. So our map is now zoomed in. As you can see, we're 500 pixels back to give Mario some space. So that's what that black layer is on the sides, because we moved the map forward 500, or we moved back 500. At a later date, I'm sure that this will change and it will become a smoother experience, and we won't have to do this, but this is the workaround that I found to make the camera component follow Mario correctly. So the next part I'm going to discuss is creating a level component, and this step isn't necessary for the demonstration, but it would be very helpful when determining if we want to switch between different levels of the map. So for this demonstration, it's only level 1, but let's say down the line I want to add more maps to the game. The level component will handle that logic of replacing the current level with the next level. So within the lib directory, I'll create a new folder called levels, new file called level option.dart and level.dart. So the level option is going to be an enum that will represent each level that we can select. It's going to have the path to that file, which is the .tmx file of the map that we created in tile.io, and then also the name. We're going to pass in the globals to that path of our level 1. Let me do the import. What was that, level 1? And the name of that world will be 1-1. I think that's all we need for this. Path name. All right, so as you can see, if we want to do level 1, world 1, level 2, world 2, level 1, we would just add these new levels within the level option enum. So that's taken care of. Now we need to come over to level.dart, create this class, level component, extends a component with a has game ref mix in. And the has game ref essentially gives us access to the Super Mario Brothers game instance anywhere with any class that we're working with. So has game ref, Super Mario Brothers game. So the first thing that we need is a level option, call it option, which is going to be the option that we will assign a little bit later. Then we need a rectangle object that will represent the bounds of this level, because we want to make sure that whenever we create a map or assign a map in Flutter, that Mario doesn't go outside of those bounds and eventually off the map or somewhere he shouldn't be. Let me import this, Flame Experimental. Then our level component, we're going to pass in the option. So when we call level component, we will specify which level we want this component to be. Then we need to override the onload method, and we essentially want to take the logic that was in here and move this into the level component class. I guess a better name for this would be level component. And we're going to use our game ref to access that world object. We're also going to set the level bounds here, which is going to be a vector2. I'm sorry, not vector2, rectangle from points. So the first level bound is going to be top left corner, so 0, 0. And the second vector2 is going to be bottom right. And so in order to get that, we would just need to know the size of the map and then multiply that by the pixel size. I'm going to change the name of map to level. Now within level, tilemap dot height, and convert it to a double, and then it's going to be the same thing. And remember, we need to multiply this vector, so we'll call tile size, which is 16 by 16, and then change this to width. Actually, I think these are misplaced. We'll put width here and height here. Okay, so that's all we need for this class. Come back over to our Super Mario Brothers game, take out those imports that we don't need, and we'll add a level component instance up here, and it can be nullable since we may not have it just yet. Make sure we do our import. So within here, we'll then, we're going to call a method called load level, which we'll create in a second, and specify the level option to be level 1. And then load level, which takes in a level option. And we're going to call this current level, actually be more representative of what we're actually dealing with. So first we need to remove this level from the component. Then we need to assign a new current level, which is going to be the level component of the option we selected. And then finally add that level component to the world. All right, cool. So nothing should change. It should be the exact same, but now we just modify the logic to handle switching between levels a little bit better. Okay, we have the level component complete. Now we need to add the platforms to the game. And the platforms are essentially the bricks that Mario stands on. Well, all the characters stand on. So we'll come back over to tile.io and create a new layer. We select new object layer, make sure it's an object layer, and title this platforms. And then for the platform layer, if I can zoom in, there we go. All we need to do is select all of these bricks, which are the platforms, and they're going to be the objects that are in that layer. So we'll grab the lasso up here and just start moving through. I'm gonna zoom out just a little bit. Okay, once all those objects are highlighted, we can click the object section and we can now see literally everything that we just highlighted. So it's pretty useful when you're trying to figure out what you've selected, what you haven't selected, just for a better understanding. So that's all we need to do within tile.io. As mentioned before, make sure that we export as, and we'll just select the map again and just override it or replace it. So that's all we need there. All right, so we got the platform layer within tile.io added. Now we need to create those platform objects by creating a platform class within Flutter. So within the lib directory, I'll create a new folder called objects, a new class called platform.dart, and this class is going to extend a position component, and within the constructor we're going to be passing in a vector2 that represents the position of each object as well as the size of each object, and we'll pass those along like this to the position component that it extends from. Also, something that we're going to do is set the debug mode value to true on this class, so that way anytime we have an instance of the platform class within our map, we'll see a pink outline of that object just to know where exactly it is in the world. Just a debug feature. Then override the future onload method, and then we need to add a rectangle hitbox, and we're going to change the collision type to be passive. Now the collision types are interesting. So there's 3 different collision types. It says that it's used to determine which other hitboxes that it should collide with. You have active, which collides with other hitboxes of type active or passive. You have passive, which collides with other hitboxes of type active. And then finally you have inactive, which will not collide with any other hitboxes. So if my understanding serves me correctly, I think this would be related to like if a player has projectiles coming out of him, maybe it hits an enemy only based on their collision type, but it wouldn't affect maybe an item in the background who has a different collision type. I think that's how that works. But just know for now that we're going to set this as passive. Then within the level component, we need to create a new method called create platforms. And this method is going to give us it's going to create platform instances for every object that was in that object layer within tile.io. Let me make sure that I call this within here before I forget. So it's going to pass in that tile map. First thing we need to do is create an object group. Call it platforms layer. And we're going to take that tile map and get those objects. Actually, tile map get layer, and specify the name of that layer, which was platform. So if platform layer equals null, then we'll throw an exception, meaning that it couldn't be found. Now we won't have this issue for this demonstration, but it's just a safety precaution. From there, we can assume that we have a valid platforms layer object. We're going to loop through each object in that platforms layer, which is a tile object. Call it obj in platforms layer.objects. So within here, we'll create a platform instance. Make sure it's the proper import, and it's not, because there is another class called platform already in dart.io, and it's used for determining which device you're on, whether it's iOS, Android, web, Chrome, whatever. But I want the platform that I just created. So we will do a manual import, call this platform, and we need to specify the position, which is going to be a vector 2 of the X and Y on that object. And the size is going to be a vector 2 of the width and height on that object. And then all we want to do is, within the game ref, access the world object and add that platform to it. Okay, that should be all we need to do. So now if we run this, we should see the same map, but we'll see a pink outline on the platform objects that are present in the world. So as you can see here, we have the same map. The coordinates of the platform object, this single object, starts at 0 on the x-axis and 208 on the y-axis, and it extends all the way through the map. But you can see the pink line starting right here, going all the way down. So we have the platform now present within our Super Mario Brothers world. Platforms are in there now. We have the structure needed for Mario to stand within the game, but we don't have Mario. So let's go ahead and add him now. We come back over to tile.io and create a new layer called actors. And actors are going to hold Mario, Goombas, Koopas, any playable character, any character within the game we will put in this layer. So we have the actors layer selected. Now what we need to do is we need to come to the beginning of the map and just select an area for Mario to be placed. I'm just going to pick right here. So I'm going to have him fall out of the sky. That way he lands on the platform. And you can of course have him start on the platform, but just to demonstrate gravity and the collision detection within the game, I'm going to have him fall out of the sky. So I select this square right here, have that object, and I need to change this name to Mario. That way we know what object layer we're looking for when looking through the actors layer within Flutter. So that is all we need right there. Be sure to export as, select that same map and just replace it. Voila. So same process. This started to become like a rinse and repeat. You put it in tile.io, come over to Flutter, but now we're going to focus on adding Mario as an object within the game. So I'm going to come in the lib directory, create a directory called actors, new file called mario.dart. First things first is we're going to be extending Mario from a sprite animation group component, essentially meaning that this component, compared to like the platform component, which is just a single static image, the sprite animation group component will be allowed to alternate between different animations throughout the updating of the game loop. So I'll explain a little bit more of that in a second, but first thing we need to do is create an enum of the different animations that Mario can possess. So we'll call enum Mario animation, and he can either be idle, meaning standing still, walking. Then we'll create a class called Mario extends sprite animation group component of type Mario animation state. Then we'll create our constructor. Oops, not class. And we'll need a position of where Mario was at on the map. And we'll also need a rectangle that represents the level bounds. And if you remember, the level bounds are what we created within the level component. So we're going to pass that value. I'll go back to it. The level bounds that we use right here. When we create Mario, we're going to pass in those boundaries of the world to the Mario object. That way he can't go in and out of those bounds, just to ensure that he stays within the realm of the world. So we'll call this level bounds. Pass the position to the constructor for the super constructor for the super. And then we have the position. For the size, we can do this within the Mario class. It's going to be, Mario's just going to be the size of a normal tile size. So he's just going to be 16 by 16. Let me do the import globals.tile size. And then we also want his anchor, which is going to be the position on Mario that represents the start of everything. If it's at the center, then that would be, his coordinates on the map would be at the center of Mario, but we want him to be on the top left. So we'll do anchor dot top left. And then I'm also going to turn the debug mode value on to true for Mario so that we can see his coordinates also. Then we need to override the onload method again. And we need to specify which animation Mario starts at. And so on the sprite animation group component, there's a variable called current, which just represents whatever current animation Mario is at. So we will need to access our animation config. Where we go, animation configs. Go to Mario. Actually, I'm ahead of myself. We want to instead create local variables that represent which animation he's at, and we need to make this come at the end as well. So this final sprite animation idle is going to equal animation configs.mario.idle. Then we need to map each of these animations that we'll be using to whatever Mario animation state that corresponds with it. So within animations, we will say we have idle is going to equal the idle. Actually, we want Mario animation state.idle is going to equal idle. And for jumping and walking, we'll add those a little bit later, but you can see the setup here. We will call whatever animation we need, assign it to a local variable, and then specify which state on the Mario animation state that animation corresponds to. And then last but not least, we just need to set current equal to the Mario animation state.idle. All right, so now we can come back over to the load component class, and now we're going to do the same thing as with create platforms, but we're going to do it for create actors. The first thing we need to do is we need to create a late Mario object, because we're going to be using this Mario instance later on for some functionality that I'll explain a little bit later. So I'm going to copy and paste this create platforms method, call it create actors, because they're essentially doing the same thing just with different layers. Actors layer, if not found, actors layer can't be found. Loop through those objects, and within here we're actually going to do a switch statement here, because since we can have multiple different objects, different type of objects within the actors layer, because it can be Mario, Goomba, Koopa, whatever it is, we're going to do a switch statement based on the name of that object to determine what we'll be adding to the game ref.world object. So object.name, in the case of Mario, we want to assign that Mario object with a new instance, and the position will be obgy.x, oops, it's a vector, vector2, obgy.x, obg.y, and then the level bounds are going to be that level bounds object that we have already. Probably need to rebuild this because, yeah. Okay, so we have our switch statement in here. I don't know if we still need these default break and flutter, but I'm gonna throw it in there just in case. So once we have Mario, we do the same thing here. And I need to delete this too. But instead of adding a platform, we're gonna add Mario. So now let's run this and see if we get the desired result. So we should see Mario within the game, and he should be levitating slightly above the platforms below him. And there we go. We have him maybe, I don't know, 200 pixels, and maybe not that much, but he's levitating like we need him to. So that's working how it's supposed to. So now Mario is in the world, he's levitating, but now what we want to do is we want to have him drop down. So we need to apply some gravity, And we also need to allow him to detect collisions. That way, once he hits the platform, he knows to stop. So we're going to be adding a few modifications to the Mario class. First, we're going to add a gravity variable. We'll just give it a gravity of 15. And that's basically saying he'll be moving down on the y-axis 15 points, because within the game, as you go down the y-axis, you're increasing the y value. So we'll be technically adding 15 points as Mario's falling until he hits something. We also need a velocity variable to represent his direction and his speed. We'll just do vector2.0 for now. And then we need a min clamp and max clamp variable. And these two variables will represent the min and max coordinates that Mario can go in between. So pretty much the level bounds that we specified, these values will be based on the level bounds that we determined in the level component. So within the constructor, we can set those values here. Min clamp is going to be the level bounds plus size divided by 2. Now we're doing size divided by 2 because we want to account for Mario's size himself in this level bound calculation. Without the size divided by 2 added, technically, if he's 16 by 16, 8 pixels of him can still go off the board, and then that can cause some disruptions with the calculations. So we'll do this to be safe, and then we'll do the same thing for the max clamp. Thought I was doing something. Max clamp. And it's going to be the bottom right because we're going top left to bottom right for the coordinates. We also need to add a circle hitbox to Mario, that way he knows that he's collidable as well. So then we need to come down here and add a few methods that will be called within the update of this class, and I can add that as well actually. So the update method is called within the game it pretty much represents the game loop. So this method will be called approximately every 0.01 seconds, and we're going to be adding methods in here to constantly update his speed and his position in the game. So one thing that I do add in here is just a check to make sure that the DT value is not greater than 0.05 actually. And the reason being is because I noticed that when navigating away from the screen, the DT value will grow and it won't hit the next iteration of the loop. So instead of each DT value being around 0.01 in time, the delta may go all the way up to like 5 seconds, and that's going to completely throw off our calculations for Mario when determining his velocity. And if he has the wrong velocity, then he could shoot across the map, he can shoot through objects, and it's all bad. So I add this little check in here as a workaround. So then we have this method that we're going to create called velocity update, and that's simply just taking that velocity value and updating its y. We're adding the gravity to the y value, and then we call that within the update method. Then we also have a method called position update, and we're going to pass in the dt here, the delta, and this is where we will determine the distance for Mario as he's moving. And remember, well, I don't know if you remember, if you're familiar, but distance is essentially velocity times time. So we'll multiply the velocity times the dt, and then his position we will update with that distance. We also want to make sure that we apply the clamps that we spoke of earlier to ensure that he doesn't go off the bounds while going through the map. So then we will add this method as well to our update. So now let's see what happens when we run the app. Okay, so we got Mario falling. Okay, so gravity's working, but he's not stopping, and that's understandable because we haven't added the logic for once he hits the platform. So let's do that right now. So in order to have collision callbacks available for Mario, we need to add a mix-in called collision callback. I'm going to close this restart this just to, because I think it's acting a little wacky right now. Alright. Got collision callbacks right there. And then with collision callbacks, we need to override a new method called onCollision, which is a set of vector 2's passed in, called intersection points, as well as a position component known as other. Okay, so within here, we can determine where Mario has collided with another collidable object, as well as what type of component he just collided with. So within here, in order to determine if Mario is colliding with the platform, we first need to do a check. If other is platform, and we can do this with anything, if other is Goomba, if other is coin, whatever it is, but we're just checking for the platform right now. So if other is platform, we then want to check and see how many intersection points were just collided. Now, since Mario has a circle hitbox, if he collides with the platform, 2 points essentially will be interacting or colliding with the platform. Because the platform is a flat line, Mario has a circle hitbox, so as a circle enters crosses a line, there are 2 points there that are directly connected at that point when they collide. So we'll do another check. If intersection points dot length equals 2, and this is how we know that we actually want to perform some type of logic to lift Mario out of wherever he's at. So we can do, we'll call, there's going to be a method we'll create, but platform position check is a method that we will create, and we're going to pass in the intersection points, and then we'll create that method down here. So void platform position check, it takes in a set of vectors. So within here, we're going to perform a little bit of logic to basically figure out the middle point of where those 2 intersection points were. So imagine the flat line, the circle comes down, the very tip of the circle is the first point that touches it, and that's 1 intersection point. As it goes further, that 1 point now spreads out to those 2 in that circle that are now at the collision point on the line. So we want the middle point of where those 2 points are to then determine how far deep in the circle hitbox has entered the platform and push Mario back up out of it. We're going to create a final vector to call it mid, which is going to equal intersection points at index 0, intersection points at index 1, and to get the midpoint, we'll add these 2 together, divided by 2. Then we need another vector 2 to represent the collision normal value, and that's going to be the absolute center minus that midpoint. So the absolute center comes native on the position component. Should not be an issue. Oh, minus. Okay, so we're subtracting the center of Mario from that middle point, and that is how we know that's how much is outside of the square. Okay, so then to find the actual penetration length, to find how much is inside, because collision normal is how much is outside, how much of the circle on Mario is outside of the platform. Now we're going to find how much is inside. So we'll call this penetration length equals, and this all might be kind of confusing. It's still a learning curve for me trying to understand all the mathematics tied to this, but just follow along with me. It'll start to make sense in the future. So we have the penetration length. We then need to normalize this collision normal value. And the definition of this isn't very explanatory. It just says normalize this, but when watching tutorials on it, I noticed that they normalize this piece of data, so I'm gonna do that here as well. And then from there, we just need to update the position, the collision normal dot scaled, and pass in that penetration length. So this method is going to be called every time we collide with a platform. Last but not least, we need to make sure we head back to the game and add a mix-in called has collision detection in order to make sure that this works properly. So now, if we run this, we should see Mario hit the platform properly. All right, let's see what happens. Okay, so Mario hits the platform, but then he continues to fall through. And the reason being is his velocity calculation is not accurate, or he doesn't have the proper boundaries set on his velocity. So in order to do that, we're going to, same way we added a min and max clamp for the boundaries he's in, we need to add a clamp for his speed as well. So we'll come back over to Mario, and within here, we can go ahead and add this value called jump speed, and we'll just give this 400. Now we need the jump speed to apply a clamp to let us know the boundaries of how fast he can go, because right now he has no boundaries. He can speed up, and that's not good. So within the velocity update, we can apply a clamp to that Y value, and the lower limit is going to be negative, that's jump speed, and the upper is 150. So this is the boundaries of how fast he can go. He can either go as fast as his normal jump speed or 150. Now with this in place, he should hit the platform and stop. You know what? We need to set velocity Y equal to that clamp. Velocity.y equals velocity.y clamp. Now if we refresh this, he hits the platform and lands perfectly, okay? We'll do it one more time just for demonstration. All right, perfect. So now his velocity doesn't go too far out, and it stays in an acceptable boundary for his landing on the platform. So Mario is in the game and he's falling properly. So the next logical step is to make some movements for him, okay? So we're gonna add movement to Mario. So come back up here, and we're gonna add some more variables to the Mario class. So first we're gonna specify the speeds that Mario can go. We'll have a min speed, min move speed, and we'll make that look 125, and then static const double max move speed, which is going to be the min move speed plus 100, just in case we ever want to change. We'll always have the min move speed the max move speed will only always be 100 more than the min move speed. And the reason we have these two different speeds is because, to my knowledge, and I could be wrong, within the Super Mario Brothers game, it seems as if Mario has a bit of a stagger when it comes to picking up his speed. When he first takes off, he's at a certain speed, but if he is consecutively running through the map at a constantly consistent speed, then his speed increases. So I'm going to replicate that by having a max move speed that he can reach if he is running at that pace consistently. We'll also have the current speed for Mario, which is going to start out as the min move speed. Boolean value is facing right equals true. This value is going to be used because we will need to know if we need to flip Mario horizontally on his axis based on the direction he's moving. So if he's moving right, we don't do any flipping, but when he comes back left, we will need to flip him around. And then H axis input, we'll have that equals 0. This will be the value to represent if he's moving left or right. If it's 0, he's standing still. If it's negative, he's left. If it's positive, then he's going right. We also need to add another mix-in called keyboard handler. That way we can use our keyboard for movement of Mario. So back within, let's see. All right, so now we need to add a new method that we're going to override. Pull on key event, takes in a raw key event and a set of logical keyboard, and we'll call these keys press. Logical keyboard key, okay, there we go. And then call the on key event, perfect. So this method is pretty much just capturing any input to the keyboard that we would have. Return super.onKey event. So from there, we want to, every time the key is pressed, we want to reset the H axis input to 0. But then we want to check and see, perform some logic to see if it's moving left or right. So the way we do that is we're adding to this value based on if the keys that are pressed, because we have the keys that have been selected on our keyboard. If keys pressed contains a logical key of arrow left, because that means we're moving left, then we'll add -1, otherwise 0. And then we'll do the inverse for if we're selecting the right key. Then we need two more methods similar to velocity update and position update. We need speed update and facing direction update. So in the speed update, we're going to check to see if Mario's idle, which means the H-axis input is 0, then the current speed is going to be set to the min move speed. Otherwise, if his current speed is less than or equal to the max move speed, then we're going to slowly increment this speed. And basically, like I said, what that's doing is he's not standing still, so while he's moving, each update we're going to add to that current speed until he maxes out that max move speed. Then within facing direction update, if the H-axis is greater than 0, then his facing right equals true. Otherwise, it's false. Also, we need to ask somebody to know if we're going to be flipping Mario or not. And so, if the H-axis input is greater than 0 and scale .x is less than 0, or the inverse of this, H-axis input is less than 0 and scale.x is greater than 0, then we would need to call flip horizontally around center. And this is a native function that's available for the, I believe it's for the position component. Let me see. Yeah, for the position component. And I think I have one of these wrong. It's greater than, less than. No, I think that's right. Then within the velocity update, we need to now modify his x value. So velocity.x is going to equal H-axis input times the current speed. And last but not least, we need to add another mix in to the game called has keyboard handler components. Alright, so if we refresh this, we're in the game. Alright, I hit the keys left and right, Mario's moving. He's not flipping how he needs to, so I might need to make some modifications somewhere. Let's see. I think this is off if it's less than 0 and scale.x is greater than 0, or if it's greater than and less than, it should flip. Let's see if that does it. Not flipping. You know what? I didn't add the methods in. Alright, so let me add speed update and facing direction update. There we go. Now he's flipping like he needs to. Alright, so as you can see, Mario's moving. Oops, but he went off the map, which isn't good. But more importantly, the camera is not following him. So once he goes off, he's just gone. So we can modify this by updating the camera component to now follow Mario directly. Within the level component class, we'll come back here and we'll create a method called setupCamera. SetupCamera. In this method, we will directly assign the camera component to follow Mario. So we'll call GameRef.CameraComponent.follow, and that target is going to be that Mario instance that I spoke of earlier, and max speed will be 1000. So if you remember, we created a local instance of Mario, a late variable, and the reason was because we need to later pass that instance into this method right here so that the camera can follow Mario as he moves through the world. And then we also need to set the bounds for this camera. So we'll call GameRef.CameraComponent set bounds, and there'll be a rectangle from points, and we'll simply pass in the level bounds top right, and level bounds top left. Now if we refresh this, we got the camera following Mario. And there's a slight stagger. As you can see, he moves and then the camera catches up. And I personally like this effect that's based on the speed that we apply to him. If we were to modify the speed, let's say let's do 6,000. It's not really a stagger. Let's do something like 1. It's going to be really dramatic, but you'll see the difference. So it's moving extremely slow to catch up to him. So you can kind of modify this and play with it how you like to, but I'll just keep it at 1,000 for now. So we got Mario moving and the camera adjusting based on his position throughout the world. Let me make sure I did this right. Should this be? No, okay. So that was incorrect on my part. When I set the anchor to be anchor dot left, top left, it wasn't accounting for his actual position. So I modified Mario's anchor to be anchor dot center. So now we're not having the issue of him going off the map by going too far left. But we have movement on Mario just as we wanted. Okay, now it's time to add jump capabilities to Mario because he can move left and right, but without the ability to jump, he's gonna die out pretty quickly. So we're in the Mario classes as we were before. We're gonna add some more properties now. So we need a vector 2 called up. We'll just call this one up. And I have the coordinates of 0, -1. We're going to use this to determine if Mario is on the ground or not, because essentially if he's not on the ground, we don't want to allow him to continue jumping. But if he is on the ground, that's the only situation where he should be allowed to jump. Then we have bool jump input. By default it's false, and then a boolean value is on ground, and that should equal true by default, false by default, since he's technically falling out of the sky. Then within the on key event, we're going to add another logical check to determine if the key that was pressed was a space bar. So instead of the extra logic, the 1 and -1 or whatever, we're simply just checking to see if the keys pressed was a space bar. If it was, then jump input becomes true, and that means that he's not jumping. Otherwise, he's not. Then we need a new update called jump update, and this one's real simple. If jump input is true and is on ground is true, then we want to allow Mario to jump, and we'll create that jump method right here. So for the jump, we need to modify his velocity to subtract the jump speed. So like I said earlier, when you're with gravity, we're going down, so we're adding y points to the y value of Mario. When he's jumping, we're subtracting values from the y coordinate of Mario because he's going up. So velocity y minus equals jump speed is on ground is now false because he's in the air. And then we also want to play some audio now to represent Mario when he's jumping. So we'll call flame audio dot play globals jump small sound effect. Let's make sure that we add the jump update to our update method for Mario. Where's that at? Here we go. Just put it here. And then down here in the collision check, or in the platform position check, if up dot passing that collision normal value, if that's greater than 0.9. So this is more of the mathematical aspect of it. I'm not exactly sure how to explain exactly what this does, but it's the inner product of that up variable that we created. And basically, if this value, when you pass in the collision normal, is greater than 0.9, that means he's going, basically, if up dot collision normal is greater than 0.9, then we set is on ground to true. And this is just more mathematical calculations when it comes to determining these things. So it can get deeper than this. I'm sure that there's a very detailed explanation on what exactly this means, but just know for now, you can do this check to determine if your main component is on the ground or not. So we have that. If we refresh this and now come over to the game, we now have Mario jumping. Okay. Cool. Now, Mario is able to jump, but you see his animations aren't looking really smooth. He still has the same idle animation throughout every type of action he can take. So what we can do is modify some of his animations. So we'll go back up to the, where were we at? Was it the constructor? No, the onload. Okay, oh, here we are. So we just need to create 2 more animations for Mario, and those are going to be walking. And we'll just call it like this. Remember, I created these animations in the animations config class prior to starting the project, so just refer to the beginning of the video if you not familiar where these are coming from. Walking and then jumping. Then we pass them in here. Mario animation state, jumping, jumping, and Mario animation state, walking for walking. Then we can create a new update method called Mario animation update. And I'll add this into the update just so I don't forget. But essentially what we're doing in this class is checking to see, is he on the ground? Or if he's not on the ground, that means he's jumping, so let's have the jump animation. Is he moving left or right? That means he's moving, let's have the walking animation. Is he standing still? Let's have the idle animation like previously. So if is on ground, if he's not on the ground, current will equal Mario state animation jumping. Else if H-axis input is less than 0 or H-axis input is greater than 0, which means he's moving left or right, current will equal Mario animation state walking. And I'll have this could really be an else statement, but I'll do else if just in case we have another type of condition of what Mario state should be. If H-axis input equals 0, then current will equal Mario animation state idle. Alright, let's refresh this and see what happens. Okay, so he's walking left and right, perfect. And when he jumps, he takes the jump animation. Okay, so the next step is Mario's pretty much complete as far as everything that he can do for now. But what we can now do is add in some enemies to the game. So, like I said earlier in the beginning of the video, Goomba will be the main enemy and focus for this tutorial. So let's go ahead and add Goomba in tile.io. So we're on the actors layer as previously mentioned. So we're going to do the same thing for Goomba, and I'll just pick 3 locations for Goomba. One right here, here, and here. Now, need to make sure that we change their names. And then, same thing as before, just export as. And that's all we need right there. Now we need to create the Goomba class in actors. So, let me stop this because we're gonna probably need to rebuild that. Call this Goomba.dart. Class Goomba extends sprite animation component. Goomba is going to take in a vector 2 for position. I think that's all we need to pass in. Yeah, I think that's it. So we'll pass that position to our super call. The size, we'll make just the tile size. We'll do vector to all global dot, hold on, gotta import. Globals dot tile size. Anchor dot top center, and animation will be animation config figs, Goomba, walking. So by default, Goomba will always essentially be walking. He doesn't really have an idle state. He's always moving. Even when he's standing still, he's still kind of pacing back and forth. So we have Goomba there. Also, we'll add a couple mix in. We're gonna need has game ref a little bit later. And collision callbacks. Now we come back to the level component, and we're just gonna copy the same logic for Mario in the switch statement, but instead of looking for the name Mario, looking for Goomba, obviously, and we're going to be creating a new Goomba instance each time. So take level bounds out, import Goomba. We already have them, and then we add Goomba to the world. So if we build this now, we should see 3 Goombas pacing pacing. They're idle technically because they're standing still, but they are moving their feet. But we should see 3 of them because that's what we put on the map in tile.io. So if we look at the map, we have our 3 Goombas making their little movements, all right? Now we got the Goombas in place, but they're not really moving right now, so kind of defeats the purpose of having enemies. So what we can do is let's add some movement to Goomba. So we'll go back to our Goomba class, add a variable for his speed. I'll double speed. We'll just give him a speed of 50. Then the way this is going to work is we will create a target position, and the target position specifies where the Goomba is going. So the target position is going to just be 50 pixels to the left. And we can create that target position based on the position that we get in the constructor of the Goomba. So let's add that in the constructor. Vector2 target position equals position. And then we're going to change the X coordinate on this target position. It's acting up again. I'm going to close this out. Okay, here we go. So target position, the X, we'll do 100 pixels actually. So he'll be moving 100 pixels to the left. And then we need to create a sequence effect. So final sequence effect, equals sequence effect. And this takes in a list of effects that will take place. So the first effect is moving towards the target position. The other one is moving back. So we'll call a move to effect. The destination will be the target position. The control will be an effect controller where we pass in the speed from up top. And then do the same thing for the following position or the following effect. He's going to go back to the original position. Same speed. Then we also need to add alternate value to be true. This means that he'll be going back and forth between these 2 effects. And then we want this to continue non-stop, so we'll set infinite to true as well. After we create that effect, we need to add to Goomba. Now if we run this, we should see the Goombas pacing back and forth 100 pixels each. There won't be any stagger between the Goombas as of right now. They're all going to be moving at the same speed, same time. But this is just for understanding of how move effects and sequence effects work within Flame. There we go. So we have our Goombas. They're now moving left and right in sync, going 100 pixels to the left, and then returning back to their original position 100 pixels to the right. Now it's time to add collision detection to the Goomba. That way when Mario jumps on his head, we can now defeat the Goomba and get him off of the map. So within Goomba, we already have collision callbacks ready. We can go ahead and add a circle hitbox within the Goomba class, similar to what Mario had applied to himself. And I'm going to copy, just to save some time, the onCollision method from Mario and put it into Goomba. So this one is going to be slightly different because instead of checking if other is platform, we're going to say if other is Mario. And also, the collision detection we're doing here is when Mario jumps on his head. So the only way that this would take place is if Mario is not on the ground. If Mario collides with Goomba while he's on the ground, that technically means Mario should take damage because he ran into Goomba. But otherwise, if he's not on the ground, then we'll proceed with the correct logic for removing Goomba from getting hit on his head. So we'll do another check to see if other dot is on ground. It's not on the ground. Then first we need to give Mario extra jump, because whenever he jumps on Goomba's head, he gets an extra bounce. Then we need to update the animation of the Goomba itself to be dead. So we'll call animation configs Goomba dead. We'll also need to update his position slightly, the Goomba's position slightly by 0.5 pixels, because when he's squashed, when he gets squashed, he goes maybe a little too deep into the platform based on pixel size and anchor and position and all that. So to make up for it, we're going to push him down slightly. I might have said it backwards, but we're going to be adding 0.5 pixels to his y-axis when he gets hit. Then we need to wait, future.delay, duration, milliseconds. So this means we're going to wait half of a second until we remove the Goomba from view. So we'll show Goomba dead is just Goomba being squashed. We want to display that for about half a second and then remove him. And since we're using a wait here, we need to add the async modifier to our onCollision call. Once the half a second has passed, then we will add the remove effect to the Goomba. So if we refresh this, let's see what this looks like. Alright, so we jump on his head. Now you see after we run into him, nothing happens. So we jump onto his head. We then remove Goomba the old-fashioned Mario way. Goomba's done. Now it's time to, we're not completely done yet, but we're about to wrap it up soon. But we need to handle the game block class. The game block class would be technically the base class that the parent class that the mystery block and the brick block extend from. The reason I created this base class, so to speak, is because both the brick block and the mystery block have similar logic, and it makes the most sense to do an extension of that class versus trying to do separate classes with their own logic. So within objects, we want to create a new file called gameblock.dart. So we'll call class gameblock extends sprite animation component with collision callbacks. And we got a few properties that we need to have here. First is a vector 2 of the original position. We need this because when Mario hits the block, we're going to bump the block up the y-axis and then slowly gravitate back down to its original position. So we need to have this variable to save it to use for it later as reference to where this block needs to go when the gravity takes place. Have a Boolean value should crumble. Well, actually I can do that now. Let me just create the constructor just so I can pass it in. Require this dot should crumble. Now the should crumble variable, that lets us know if this block should disappear once it's been hit or should remain on the screen. The mystery blocks cannot crumble because they remain on the screen after they've been hit. They just change to a different sprite. The brick blocks, I believe some of them can remain on the screen. Others actually crumble and turn to brick and disappear. So we'll have that value. This should crumble value will be set to true in the brick block, and it will be a 50-50 chance in the brick block, and then false for the mystery block. Final double hit distance equals 5. This is how far up the y-axis it goes, the block goes when it gets hit. The gravity is much slower because it's not that much of a distance it needs to travel. Then within the constructor, we need position, animation. So what we need to do in the constructor is first set that original position equal to the position that we get from the constructor. And we also need to add a rectangle hitbox. Now we need to override the update method because within this call, we are going to be moving the block either, well, yes, we're moving the block back to its original position after it's been hit. So double delta. So within here, if y of this game block does not equal the original position's y, that means it's been hit. We're going to slowly add gravity in. Then we have a method called hit that we will use in the other blocks as well, but this is the logic that takes place once Mario hits the block. If should crumble, we're going to wait, let's see, we're going to wait a quarter second, and then we will remove it from view. If otherwise it should not crumble, that means it stays on the screen. We're going to move it up the hit distance, as well as play the sound of Mario bumping his head on the block. Play globals dot. Then we need to modify the on collision, and I'm going to copy this again because that's such a long method to write. And actually, I'm going to copy it from Mario because this is more of what we need. So we're checking to see if other is Mario, and we need the midpoint again for this logic. So we're not going to do a platform position check, but we'll get the mid value. Now, to make sure that we're hitting from the bottom, well, we pretty much want to make sure he only hits from the bottom, because if Mario hits the block from the side or on top, he technically didn't bump his head on the block, and it's irrelevant to perform any action at this point. So we can do that with this logic. If mid.y greater than position.y plus size.y minus 4. And this minus 4 is just to add a little bit of cushion in case Mario is still on the bottom but not directly under it. So he can be, maybe let's say he's only 2 pixels under the block and he goes up, he still technically hits the block. So this is just for some cushion. Then we'll do if mid.y is less than position.y plus size.y plus 4. And last but not least, if the velocity of Mario, if Mario's velocity is less than 0, that means he is going up. So when Mario is falling down, his velocity is positive, but when he's going up, his velocity is negative. So we need to make sure that his velocity is under 0 as well. So if all of those conditions pass, then we can actually call the hit method. And since Mario bumps his head, we also want to set his velocity to 0 to ensure that he can't keep going within the block. And then after all that, we need to call the platform position check on Mario. All right, so that is essentially our game block class, and this is what the mystery block and brick blocks will extend from. Now we need to add the mystery block and the brick blocks. So let's head back over to tile.io, and same as before, create a new layer, new object layer. We'll call this one blocks. And within blocks, I'm going to just select the blocks for this game. So let's see, we'll select each of these. I'm only going to do the first 7 that we see in the view. There's blocks throughout the rest of the game, but just for this, that way I don't have to go through and select all of them. We'll just do this right here. All right, so this block is mystery block. So give this name mystery. Oops. Mystery. This is a brick. Mystery. Brick. Mystery. And that's a mystery as well. And brick. Okay. So now that we got these in here, what I want to do is I want to paint over the background of these bricks, because now that they're actual components that are going to be in our game, I don't want the background to display these bricks anymore in case they disappear or move. We want it to be just a blue background in the back. Since we already know the position of them, right? We don't need them anymore. So I'm just going to paint over them. I selected a blue, just a blue square on the tile set, and now I'm just going over and painting them. I'm doing above them and below them and to the side of them because some of the colors bleed over into the next square. So make sure you take this approach if you're trying to duplicate this. Okay, so we have our blocks. You see right here, we have 4 mystery and 3 bricks. So then I hit save as, export, I'm not sorry, save as, export as. They probably do the same thing, but I just like export better. Sounds safer. Hit replace. And our blocks are now within our map. Now let's add the mystery block in Flutter. We'll go to our objects directory, new file called mystery block.dart. In this class, mystery block extends the game block. And I'm gonna close that as normal because we just modified our map. And the only thing that we're passing in to the constructor is a position as always. So the animation is going to be animation configs dot block dot mystery block idle because it hasn't been hit yet. Then position will be position, and it should crumble is false because the mystery block cannot crumble. Then we also need to have a variable called hit that will represent if this block has been hit or not. That way when we need to go and override our method, we're going to do some logic in here that says if it hasn't been hit yet, or if hit is false, then we set hit to true, just to make sure it can't happen again. And then we need to update the animation to be the block, mystery block that was hit. So that's all we have to do for the mystery block. Then come back over to the level component. Same thing as create actors. We're going to do one for create blocks. Let's see, create blocks. And it's going to be similar to the actors because there's 2 different types of blocks. So we'll have a switch statement here as well. Create blocks, layer, blocks, blocks, layer cannot be found, blocks, layer. And in the case of mystery, we're going to create a mystery block, and we'll just add it to the map like that. Okay, make sure that looks right. I think that's right. So now if we run this, we should only have 4 mystery blocks because we haven't added the brick blocks yet. But there should be 4 mystery blocks that Mario can interact with. All right, 4 mystery blocks. Let's see if we hit one. All right, perfect. So that's working how it needs to. Mystery blocks are in there. Brick blocks are going to be fairly simple and similar. So we'll come to objects, create a brick block.dart file. I'm going to copy and paste this into brick block and make modifications where needed. Brick block. Let's see here. So the animation for this would be brick block idle, should crumble. We're actually going to pass that in from the constructor. Required bool should crumble, and set that here. Then this is similar, but it's going to be the brick block hit, and we're also going to play a sound of, actually what we need to do is, this is going to be a little bit different. So if should crumble, then that means that we want the animation configs brick block hit, and we also want to play a sound of a brick crumbling. I have a sound effect for that as well. Close break block sound effect. I'll take this out. Okay. We don't need that hit. All right, and then in the level component, same thing for mystery. Just gonna copy this. Now something to notice is we're adding a should crumble value, and the should crumble value is like 50-50, so I'm going to just use a random generator. I call it random from the math class, next bool. So this will be true or false, just depends on, I don't know. It depends on something, but I'm not exactly sure what it depends on. But it's going to be either or, depending on what time it's called. So then we pass in the brick block, and then we'll refresh this and see what this looks like now. All right, so we got our brick blocks. So some of these should just get bumped. Other brick blocks should crumble. Okay, that one bumps, that one crumbled, and that one bumped. All right, I'll do that one more time. Okay, so brick block, mystery block have now been applied to the game. Last but not least, I'm going to explain how we can actually pause the game while Mario is playing, just in case you got to take a break or something. So come back to the Mario class. Let me take out this import. So for Mario, we want to add another mix-in that has GameRef mix-in, because we're going to need to call the game itself to pause its engine. So Super Mario Brothers game. Then we'll have a value called paused. And it's going to be false initially. Then within the on keys pressed, we're going to say if keys pressed dot contains what key for pausing? We'll just say the A key will allow you to pause the game. So logical keyboard key A. Is it letter key A? Key A. If that is pressed, then we're going to call the pause method. And the pause method will look like this. Essentially, first we're going to play flame audio dot play globals dot pause sound effect. Then if paused, that means it's currently paused right now. What we want to do is resume the engine. So we'll call gameref dot resume engine. And if it's not paused, that means we want to pause the game. So gameref dot pause engine. And then we will set pause equal to its inverse, just like that. So now let's see what happens. We refresh this. If we hit the A key, pause the game, hit the A key again, game resume. And that's essentially, that's all the components for building the first tier of this series. With all of the components described in this video today, from Small Mario, the enemies, the blocks, creating your own map, hopefully you got a better understanding of just how simplistic Flutter and Flame can be, but how complex it can be to be able to recreate a game such as Super Mario Brothers for the Super Nintendo Entertainment System. Like I mentioned before, this is going to be one video in a series of 3, so please be on the lookout for future iterations of this series. As always, if this video was helpful, please like, comment, subscribe. Let me know in the comments what you think about Flame, or even how I did instructing you on how to use the Flame engine. Until next time, this is Trey Codes, signing off.